Preface. Welcome to Introductory Statistics, an OpenStax resource. This textbook was written to increase student access to high-quality learning materials, maintaining highest standards of academic rigor at little to no cost. The foundation of this textbook is Collaborative Statistics by Barbara Alowski and Susan Dean. Additional topics, examples, and innovations in terminology and practical applications have been added, all with a goal of increasing relevance and accessibility for students. About OpenStax. OpenStax is a nonprofit based at Rice University, and it's our mission to improve student access to education. Our first openly licensed college textbook was published in 2012, and our library has since scaled to over 25 books for college and AP courses used by hundreds of thousands of students. OpenStax Tutor, our low-cost personalized learning tool, is being used in college courses throughout the country. Through our partnerships with philanthropic foundations and our alliance with other educational resource organizations, OpenStax is breaking down the most common barriers to learning and empowering students and instructors to succeed. About OpenStax's resources. Customization. Introductory Statistics is licensed under a Creative Commons Attribution 4.0 International (CC BY) license, which means that you can distribute, remix, and build upon the content, as long as you provide attribution to OpenStax and its content contributors. Because our books are openly licensed, you are free to use the entire book or pick and choose the sections that are most relevant to the needs of your course. Feel free to remix the content by assigning your students certain chapters and sections in your syllabus, in the order that you prefer. You can even provide a direct link in your syllabus to the sections in the web view of your book. Instructors also have the option of creating a customized version of their OpenStax book. The custom version can be made available to students in low-cost print or digital form through their campus bookstore. Visit your book page on openstax.org for more information. Errata. All OpenStax textbooks undergo a rigorous review process. However, like any professional-grade textbook, errors sometimes occur. Since our books are web-based, we can make updates periodically when deemed pedagogically necessary. If you have a correction to suggest, submit it through the link on your book page on openstax.org. Subject matter experts review all errata suggestions. OpenStax is committed to remaining transparent about all updates, so you will also find a list of past errata changes on your book page on openstax.org. Format. You can access this textbook for free in WebView or PDF through openstax.org, and in low-cost print and iBooks editions. Coverage and scope. Chapter 1, Sampling and Data. Chapter 2, Descriptive Statistics. Chapter 3, Probability Topics. Chapter 4, Discrete Random Variables. Chapter 5, Continuous Random Variables. Chapter 6, The Normal Distribution. Chapter 7, The Central Limit Theorem. Chapter 8, Confidence Intervals. Chapter 9, Hypothesis Testing with one sample. Chapter 10, Hypothesis Testing with two samples. Chapter 11, The chi-square distribution. Chapter 12, Linear Regression and Correlation. Chapter 13, F distribution and one-way ANOVA. Alternate sequencing. Introductory Statistics was conceived and written to fit a particular topical sequence, but it can be used flexibly to accommodate other course structures. One such potential structure, which fits reasonably well with the textbook content, is provided below. Please consider, however, that the chapters were not written to be completely independent, and that the proposed alternate sequence should be carefully considered for student preparation and textual consistency. Chapter 1, Sampling and Data. Chapter 2, Descriptive Statistics. Chapter 12, Linear Regression and Correlation. Chapter 3, Probability Topics. Chapter 4, Discrete Random Variables. Chapter 5, Continuous Random Variables. Chapter 6, The Normal Distribution. Chapter 7, The Central Limit Theorem. Chapter 8, Confidence Intervals. Chapter 9, Hypothesis Testing with one sample. Chapter 10, Hypothesis Testing with two samples. Chapter 11. The chi-square distribution. Chapter 13. F distribution and one-way ANOVA. Pedagogical foundation and features. 1. Examples are placed strategically throughout the text to show students the step-by-step process of interpreting and solving statistical problems. To keep the text relevant for students, the examples are drawn from a broad spectrum of practical topics, including examples about college life and learning, health and medicine, retail and business, and sports and entertainment. 2. Try-it practice problems immediately follow many examples and give students the opportunity to practice as they read the text. They are usually based on practical and familiar topics, like the examples themselves. 3. Collaborative exercises provide an in-class scenario for students to work together to explore presented concepts. 4. Using the TI-83, 83+, 84, 84+ calculator shows students step-by-step instructions to input problems into their calculator. 5. The technology icon indicates where the use of a TI calculator or computer software is recommended. 6. Practice, homework, and bringing it together problems give the students problems at various degrees of difficulty while also including real-world scenarios to engage students. Statistics labs. These innovative activities were developed by Barbara Alowski and Susan Dean in order to offer students the experience of designing, implementing, and interpreting statistical analyses. They are drawn from actual experiments and data gathering processes and offer a unique hands-on and collaborative experience. The labs provide a foundation for further learning and classroom interaction that will produce a meaningful application of statistics. Statistics labs appear at the end of each chapter and begin with student learning outcomes, general estimates for time on task, and any global implementation notes. Students are then provided with step-by-step guidance, including sample data tables and calculation prompts. The detailed assistance will help the students successfully apply the concepts in the text and lay the groundwork for future collaborative or individual work. Additional resources. Student and instructor resources. We've compiled additional resources for both students and instructors, including Getting Started guides, an instructor solution manual, and PowerPoint slides. Instructor resources require a verified instructor account, which you can apply for when you log in or create your account on openstacks.org. Take advantage of these resources to supplement your OpenStax book. Community Hubs. OpenStax partners with the Institute for the Study of Knowledge Management in Education, ISKME, to offer community hubs on OER Commons, a platform for instructors to share community-created resources that support OpenStax books, free of charge. Through our community hubs, instructors can upload their own materials or download resources to use in their own courses, including additional ancillaries, teaching material, multimedia, and relevant course content. We encourage instructors to join the hubs for the subjects most relevant to your teaching and research as an opportunity both to enrich your courses and to engage with other faculty. To reach the community hubs, visit www.oercommons.org/hubs/OpenStax. Partner resources. OpenStax partners are our allies in the mission to make high-quality learning materials affordable and accessible to students and instructors everywhere. Their tools integrate seamlessly with our OpenStax titles at a low cost. To access the partner resources for your text, visit your book page on openstax.org. About the authors. Senior contributing authors. Barbara Alowski, De Anza College. Susan Dean, De Anza College. Contributing authors. Birgit Aquilonius, West Valley College. Charles Ashbacher, Upper Iowa University, Cedar Rapids. Abraham Biggs, Broward Community College. Daniel Bermaher, Nazareth College. Roberta Bloom, De Anza College. Brian Blunt, Kentucky Wesleyan College. Ernest Bonnet, Portland Community College. Sarah Boslaw, Kennesaw State University. David Bosworth, Hutchinson Community College. Sherry Boyd, Rollins College. George Braden, University of Central Arkansas. Jing Chong, College of St. Mary. Laurel Chiappetta, University of Pittsburgh. Lenore Desilitz, De Anza College. Matthew Einson, Prescott College. Anne Flanagan, Kapiolani Community College. David French, Tidewater Community College. Mo Jarity, De Anza College. Larry Green, Lake Tahoe Community College. Michael Greenwich, College of Southern Nevada. Ina Grushko, De Anza College. Valier Hauber, De Anza College. Janice Hector, De Anza College. Jim Helmreich, Marist College. Robert Henderson, Stephen F. Austin State University. Mel Jacobson, Snow College. Mary Jo Kane, De Anza College. Lynette Kenyon, Collin County Community College. Charles Klein, De Anza College. Alexander Kolovos, Sheldon Lee, Viterbo University. Sarah Lenhart, Christopher Newport University. Wendy Lightheart, Lane Community College. Vladimir Logvenenko, De Anza College. Jim Lucas, De Anza College. Lisa Marcus, De Anza College. Miriam Masulo, SUNY Purchase. Diane Matios, De Anza College. Robert McDevitt, Germanna Community College. Mark Mills, Central College. Cindy Moss, Skyline College. Nydia Nelson, St. Petersburg College. Benjamin Ingwudike, Jackson State University. Jonathan Oakes, Macomb Community College. Carol Olmsted, De Anza College. Adam Pennell, Greensboro College. Kathy Plum, De Anza College. Lisa Rosenberg, Elon University. Sudipta Roy, Kankakee Community College. Javier Rueda, De Anza College. Yvonne Sandoval, Pima Community College. Rupinder Sekin, De Anza College. Travis Short, St. Petersburg College. Frank Snow, De Anza College. Abdulhamid Sukar, Cameron University. Jeffrey Taub, Maine Maritime Academy. Mary Teagarden, San Diego Mesa College. John Thomas, College of Lake County. Philip J. Varecchia, York College of Pennsylvania. Dennis Walsh, Middle Tennessee State University. Cheryl Wortman, University of Prince Edward Island. Carol Wiedemann, St. Petersburg College. Andrew Wiesner, Pennsylvania State University.